Chapter 11.2 Combinations. A combination is a selection of a group of objects taken from a larger group for which the kinds of objects selected is important, but order is not important. The biggest difference between a permutation and a combination is that in a combination, order does not matter. So when we think about how we say locker combination or the combination to the lock, that's actually a permutation because the order of the numbers, the three numbers that you have typically on a lock to open it, you can't put them in any order. It has to be in a specific order to open the lock. So that's really a permutation, not a combination. Example, all the three-letter combinations of the letters P, Q, R, and S are PQR, PQS, PRS, and QRS. Arrangements such as PQR and RPQ, which have the same letters, they both have P, they both have Q, and they both have R, they're just in different orders. Those are the same combination. They would be different permutations because the order is different, but they are the same combination because for combinations, order does not matter. The notation NCR represents the number of combinations of n items taken R at a time, where n is greater than or equal to R, and R is greater than or equal to 0. We have similar notation to permutations. For combinations, we have C bracket n comma R, or most common, we have subscript n C subscript R. Or another way that we didn't see with permutations is we can have brackets, and then inside the brackets, vertically, we have n and then R below. It's not a fraction, there is no fraction line. It's just n at the top of the brackets and R at the bottom. So that means a combination. Then the formula for combinations is n factorial divided by r factorial times n minus r factorial, where n has to be greater than or equal to r, and r has to be greater than or equal to 0. To enter combinations in your calculator, you can put the n value, then math, then over to probability, so it might be 2 arrows over, and then not 2, now that's 3. 2 is permutation, 3 is combination, and then you enter your R value. In a Casio, you enter your n value, then option, then F6, then F3, then this should say F3 again, F2 is permutation, F3 is combination, and then you enter your R value. Note, the number of combinations of n items taken R at a time is equivalent to the number of combinations of n items taken n minus R at a time. So NCR is equal to NCn minus R. Combinations and the fundamental counting principle. When determining the number of possibilities in a situation, if order matters, it's a permutation. If order does not matter, it's a combination. Example, how many ways can the debate club coach select a team from 6 grade 11 students and 7 grade 12 students if the team has 4 members? So a team, in this case, it's not saying there's like a captain or any special position for the team, it's just saying a team. So it doesn't matter what order the team is selected. The same 4 members in any order would be the same team. So this would be a combination because order does not matter. So we have 6 grade 11 students that we're choosing from and 7 grade 12 students that we're choosing from. So our total students would be 6 plus 7, which is 13 students total. And we are choosing 4 of them. So n is 13 and r is 4, and it is a combination because order doesn't matter in this case. So then we have 13C4, which equals, we can use our formula. It was n factorial, which is 13 factorial, over r factorial, which is 4 factorial, times n minus r, so 13 minus 4 in brackets, factorial. We can simplify this. We get 13 factorial over 4 factorial times 13 minus 4 is 9 factorial. Then we can calculate. Fraction, top of the fraction is 13 factorial. Bottom of the fraction is 4 factorial times 9 factorial, which gives us 715 ways to select a debate club of 4 students. Next example, how many ways can we select a debate club with 4 members, only one of whom is in grade 11? Again, the order doesn't matter. Whichever 4 members we have, doesn't matter what order they're selected in, it's still the same group. So it's a combination. We want one student to be in grade 11. And the remaining students to be in grade 12. There's 4 members total, so we would have 3 grade 12. So then we need to select one grade 11 from the number of grade 11s that we have, which was 6 grade 11s. So we're choosing one grade 11 from a group of 6, so 6C1. And is going to mean times. We're choosing 3 grade 12s. There was 7 grade 12s to choose from, so 7C3. Then we calculate that. We do 6 math over to probability, number 3 for combination, and we are choosing 1 from 6, which is 6 different ways to get that, times 7 math probability, number 3, we're choosing 3 from 7 as a combination is 35, and then 6 times 35 is 210 ways to select a team of 4 with 1 grade 11. Just a note here. The word or in these questions means add, and the word and means multiply. Combinations with cases. Example, you are writing a social studies exam. You need to answer a specific number of questions from each section of the exam. How many different selections are possible if A, you must answer 2 of the 4 questions in part A and 3 of the 5 questions in part B. So 2 of the 4 questions in part A. The order doesn't matter on a test. Doesn't matter if you start at the end of the test or the beginning of the test. You've still answered the questions. So we know it's a combination. And answering 2 of 4 questions in part A would be 4C2. Then you have to answer 3 of 5 questions in part B. So that would be, you have 5 questions to choose from. It's a combination. You have to answer 3 of them. And we have the word and here. Remember, and means multiply. Then we have 4C2 times 5C3. We can calculate that. For math, probability number 3, 2. So 4C2 is 6. Then 5C3 is 10. 6 times 10, which equals 60 different possible selections. Part B, you must answer 2 of the 4 questions in part A. So same thing, 4 choose 2 and multiply at least 4 of the 5 questions in part B. So that means you could choose 4 of the questions in part B, or we could choose 5 of the questions in part B to answer. Then we have 2 different cases. Case number 1 is 4 questions from part B. And in that case, we have the 2 questions we choose from part A, so 4C2, times the 4 questions from part B. We calculate that. 4 choose 2, we have from above, that was 6. Then 5C4 is 5, so 6 times 5, which is 30. That's for case 1. Or we have case 2, which is 5 questions from part B. For case 2, part A, we're still getting 2 questions from part A, so 4C2 times, this time we're doing 5C5 for part B. 4C2 is 6 times 5C5 should be 1. There's only one way to choose 5 questions from a group of 5 questions. So 6 times 1 is 6. And then we have or between the 2 cases, which means we are adding the numbers from the 2 cases. So we get 30 plus 6, which equals 36 possible selections. Example, a bag contains 7 black marbles and 6 red marbles. How many ways can you draw groups of 5 marbles if at least 3 must be red? So at least 3 must be red, and we're drawing groups of 5. So that's 3 red or 4 red or 5 red because we're drawing groups of 5 and at least 3 have to be red. So we can have minimum number of red is 3, or we can have 4, or maximum number of red would be the total group size, which is 5. Then we have 3 cases. Case number 1 would be 3 red and 2 black, so that we have 5 for our group. Or case number 2 is 4 red, which means then we'd only have 1 black. Or case 3, we could have 5 red, which then we would have 0 black. Again, the order doesn't matter, so it's a combination. For case number 1, 3 red. How many red do we have to choose from? We have 6 red marbles and we have 7 black marbles. So 3 red would be 6C3, and means times 2 black. We have 7 to choose from, so 7C2. Or is plus. Case number 2 is 4 red, so we have 6 to choose from, 6C4, and is times 1 black. We're choosing from 7 black, 7C1. Or is plus. Case number 3, 5 red, so we have 6 red total. We are choosing 5, and is times. We have 7 black and we are choosing 0 of them. Then we can calculate. 6C3 gives us 20. 7C2 is 21. Plus 6C4 is 15 times 7C1, that should be 7. There's 7 ways to choose 1 from a group of 7, plus 6C5 is 6 times 7, that should say C0, not B0. 7C0, and that's 1. There's only one way to choose nothing. You just choose nothing. And then we continue to calculate. 20 times 21 is 420, plus 15 times 7 is 105, plus 6 times 1 is 6, and then we add them all together. 420 plus 105 plus 6 is 531. So 531 ways to draw groups of 5 marbles with at least 3 red. Simplifying expressions and solving equations with combinations. Example, express in factorial notation and simplify. N minus 1 C3 times 1 over n minus 2 C3. Start with the formula for a combination. NCR equals n factorial over n minus r factorial times r factorial. in the combinations we have, n minus 1, that represents our n in the general formula, and 3 is r. And here, n minus 2 is our n value, and 3, again, is the r value. Let's plug these values into the formula. We get n minus 1 C3 times 1 over n minus 2 C3 equals the first set of brackets plugged into the combination formula. The n value is n minus 1 in this case, so n minus 1 in brackets factorial. Then we have n minus 1 minus the r value, which is 3 in brackets factorial, and then the r value, which is 3 factorial. Times, then we have our second set of brackets, which is 1 over the combination, so 1 over n factorial is n minus 2 in this case, so n minus 2 in brackets factorial, over n minus r, which is n minus 2 minus 3 factorial, and then r factorial, so 3 factorial. So we have a fraction within a fraction here. And then we just start to simplify. The first fraction is n minus 1 in brackets factorial divided by n minus 1 minus 3 is n minus 4 in brackets factorial times 3 factorial. The second set of brackets, we are dividing by a fraction, so we can multiply by the reciprocal. So we get 1 times the reciprocal of the second fraction, which is n minus 2 minus 3 factorial times 3 factorial over n minus 2 factorial, which just becomes n minus 2 minus 3 is n minus 5 factorial times 3 factorial divided by n minus 2 factorial. The fractions are being multiplied, so I can think of them as one fraction. We have a 3 factorial on top and a 3 factorial on bottom. Those can divide out. Then I can change n minus 1 factorial. I can write it as n minus 1 times n minus 2 factorial over n minus 4 factorial. The second fraction, we have n minus 5 factorial on top and n minus 2 factorial on bottom. So since I split up the n minus 1 factorial to n minus 1, n minus 2 factorial, now I have n minus 2 factorial top and bottom, and I can divide those out. Then I have n minus 1 on top divided by n minus 4 factorial. I can write as n minus 4 times n minus 5 factorial. The second fraction, I have n minus 5 factorial over 1. And then I have n minus 5 factorial divided by n minus 5 factorial. I can divide those out. And I am left with n minus 1 over n minus 4. So we put it into factorial notation using the equation for combinations, and then we simplified as much as we could. Next one, solve for n if 720 times nc5 equals n plus 1 p5. So this is combination. And this is a permutation. the formula for combination NCR equals n factorial over n minus r factorial times r factorial. And the formula for permutation NPR is n factorial over n minus r factorial. The n value here is just n, and the r is 5. In the permutation, the n value is n plus 1, and the r value is 5. Then in factorial form, I can write this as 720 times the factorial form of the combination NC5 would be n factorial over n minus 5 factorial times 5 factorial. And that is equal to our permutation, which would be n value, which is n plus 1 in this case, factorial over n value minus r, n value is n plus 1 in this case, and then minus 5 factorial. Then I want to do what I did above, where I write some factorials as multiples of other numbers until I can get equivalent factorials on top and bottom, and then can divide them out. On the left side, 720, I can write n factorial as n times n minus 1 times n minus 2 times n minus 3 times n minus 4, and then times n minus 5 factorial, divided by n minus 5 factorial times 5 factorial. So now I have n minus 5 factorial on top and bottom, and I can divide those out. And on the right side, I have n plus 1 factorial divided by n plus 1 minus 5 is n minus 4 factorial. On the left side, I then have, I'm going to multiply the 720 into the fractions, so 720 times n minus 1 times n minus 2 times n minus 3 times n minus 4 divided by 5 factorial. Let's calculate that. 5 factorial is 120. And 720 and 120 can be simplified. 720 divided by 120 is 6. So we get 1 on the bottom and 6 on the top. On the other side, we have n plus 1 factorial over n minus 4 factorial. Let's rewrite n plus 1 factorial so that we can get an n minus 4 factorial. So we have n plus 1 times n plus 1 minus 1 would just be n, times n minus 1 times n minus 2 times n minus 3, and then times n minus 4 factorial, divided by n minus 4 factorial. Then we have n minus 4 factorial top and bottom, can divide those out. We then have 6 n minus 1, n minus 2, n minus 3, n minus 4 on the left side. On the right side, we have n plus 1, n minus 1, n minus 2, and n minus 3. And then I should see that I have common factors on each side of n minus 1, n minus 2, and n minus 3. So if I divide both sides by n minus 1, n minus 2, n minus 3, Then on the left side, we have n minus 1 divides out, n minus 2 divides out, n minus 3 divides out, and we are left with 6n times n minus 4. And on the right side, n minus 1 divides out, n minus 2 divides out, n minus 3 divides out. And we are left with n plus 1 times n. Oh, and there's also a common factor of n on both sides. I should have added that up there, but that's okay. I can divide that here. Divide by n, then n divides out, and n divides out. And then we are left with 6 times n minus 4 equals n plus 1. And then we multiply 6 into the brackets. We get 6n minus 24 equals n plus 1. And then we solve for n by isolating n on one side of the equation. I'm going to subtract n here. Then I get 6n minus n is 5n equals, I'm going to add 24 to both sides, and we get 24 plus 1 is 25, and then divide by 5, and we get n equals 5. That brings us to the end of Chapter 11, Lesson 2.